Hey everyone, here we are with another practical guide, and this practical guide is division. Again, with division, just like most things in our first unit here, things you'll have to remember is our place value. Our place value, which states you have these positions and our numbers, and these positions have names. This one here is, of course, we have our tens, our ones. The first place value is called tenths. The second place value is called hundredths. The third one is thousandths. And this tenths, what does tenths means? It means you have something out of 10. Hundredths literally means something out of 100, and thousandths literally means you have something out of 1,000. And this is going to be really important when we're changing our fraction into a decimal. So you should be able to see the other videos, and those other videos go through the real conceptual meaning of division. What does it mean to divide, making groups of or equal groups, yada, yada, yada. This one here is a straight up practical how-to. So let's just jump right into it. We have an example here. This was from our homework. We have 345. Ooh, that's real funky. Let's rewrite that. 345 is divided by 12, or split up into groups of 12. I can rewrite this as a fraction. 345 is split up into groups of 12. And then from here, what I can do is start reducing. I can start simplifying. To simplify, we should say the simplifying is just building off of our concept of equivalent fractions. Okay, so I have 3 6, and I can divide both of these by 3. When I divide both by 3, the numbers change, but we can see the value stays the same. 3 is half of 6, 1 is half of 2. So they are called, the values are different. Let me re-say that. The numbers are different, the digits are different, but the value is the same, and this is the concept of equivalent fractions. All right. So over here, we're going to simplify using this understanding, which is something from grade 4. We know that 12 is divisible by 2, but 5 is not because it's an odd number. So I move to my next prime number. My next number is 3. My divisibility rule for 3 states if I add up the digits of my number and that sum is divisible by 3, then this number is divisible by 3. I have 5 plus 4 is 9 plus 3 is 12. Therefore, this number is divisible by 3. Both numbers are divisible by 3, and I'm going to have 12 divided 3 is 4, and 45 divided 3 is 15, 300 divided 3 is 100, so I have 115. Now these ones here, again, even or odd number can't be divided by 2, even number can't be divided by 5. I can't reduce this anymore. Now that this is in its simplest form, I'm going to then transfer this into my other way to divide, which is long division. Once this is transferred, I'm going to say, well, how many 4s go into 15? How many 4s go, 115. How many 4s go into 115? And now I'm just going to divide using my traditional or my standard algorithm. Here, how many 4s go into 11? Well, 2. 2 groups of 4 is 8. So if I take out 2 groups of 4 from 11, that's the same as taking out 8 away from 11, and I'm left with 3. Next, I move down, bring my 5 down because I moved to my next place value. How many 4s go into 35? Well, that's going to be 8. 8 groups of 4 is 32, and I'm left with 3. And there we have it. There's my answer. How many groups of 4 go into 25? Well, there are 28 groups of 4. What's left over? 3 out of my group of 4. And that's going to work every single time. Now from here, you can go one step further. If you want to change it into a decimal, you'll have to look at your remainder and say, okay, well, I have 3/4. I need to use my equivalent fractions to find a denominator that is either 10, 100, or 1,000. I know 4, it can't scale to 10, but 4 can scale to 100. I'm going to say over here, all right, well, I have this remainder. I'm going to scale 4 to 100. How do I do that? Multiply by 25. If I multiply the bottom, in order to keep the ratio the same, I have to multiply the top. 3 times 25 is 75. Now I have my new fraction, which has the same value. So I'm going to rewrite 28 whole groups with 75 hundredths. Now, since I have 75 hundredths, that means how many hundredths do I have? I have 75. So I write my wholes, 28 wholes, 0.75. If you don't want to go through all this, what you can also do, you can find your decimal over here too. With this one, I'm done with my wholes. That's just like over here, done with your wholes, and now you're working in your remainders, in your, well, decimals. So I finish with my wholes and I move now into my tenths. With these three wholes, this three wholes now changes into 30 tenths. How many fours go into 30 tenths? Well, that's 7. 7 groups of 4 is 28, and I have a remainder of 2. Now that I'm done with my tenths, I continue on. I move into my hundredths. I bring my 0 down, and my 2 tenths are now 20 hundredths. How many 4s go into 20 hundredths? Well, 5 do, which is the same as 20, nothing left over. And as you can see, you have 28.75, which is the same as 28.75. And that works for any number at all. This video is going on a little long, so I'll just go through one more example, but instead of talking through it, I'm just going to go through the motions and hopefully you can follow along with us. Here we go. This is also from the homework. You have 2,516 is divided by 16. I'm going to rewrite this as 2516 over 16. I know that these are both even numbers, so they can both be divided by 2. If they both divide by 2, 16 turns into 8, and this one turns into, quick math, 1258. They're both even numbers again, therefore divide by 2, divide by 2. 8 divided by 2 is 4, and this one, quick math, 629. And no, that's it. That's as simplest as we can get. Because this is the simplest form, I'm going to then change it into my long division. How many 4s go into 629? Well, 4 goes into 6 one time, which is the same as 4. 2, bring down the 2, that's 5, which is 20. Bring down the 2, bring down the 9. That's 7 times, which is 28, with remainder 1. Come back over here. How many 4s go into 629? Well, 157. What's left over? I have 1 out of 4. I know that 1 out of 4 can scale to 100 by timesing 25, which means I times 25 on the top, 25 hundredths, which I'm left with 157 and 25 hundredths, or 0.25. And there you have it. This works for any single number as long as you can put it into the fraction form, find common factors, divide both the numerator and denominator by a common factor until it's the simplest form, change it into our long division standard algorithm, divide these simpler numbers, and then you can get your how many groups with the remainders, and those remainders can then be changed into our place value units. With these place values, you can then change it into a decimal. Hope that helps. If you have any questions, email me. I'll get back to you as soon as I can. I'll see you in the next one.